signal, making it more consistent, give it some substantial gain. Also take a really good look at the front to back ratio and the front to side ratios, you know, to knock out the noise. That's really important, by the way, when it comes to beam antennas. You not only want to increase the signal on the transmit, but you want to increase the signal on the receive, but you also want to decrease the noise off the sides and the noise off the back, whether that's what we call QRN, which is just noise in the environment, you know, electrical noise, industrial noise, power supply noises, or QRM, you know, other people talking, you know, whether you're talking to a repeater and you know, you're hearing other repeaters in the same frequency coming from other directions. You know, a high gain omnidirectional antenna is nice. It'll increase your signal into the repeater you want to talk to. But if it's also increasing the signal from repeaters that are not that far away on the same, or even far away on the same frequency, well, that's no good. That's the power of a beam. It's really neat. So that was the goal. That's basically it. And I will say that Heartland Radio, TV, and Electronics, with Mr. Joe and Patty Lepica, the owners up there in Willoughby, Ohio, they are one of my resellers, and they were so excited about it. They came down actually last year to see me at the Dayton Hamvention, and good friends from 30 years ago, so we became reacquainted. He's an expert and I'll let Joe, you know, introduce himself formally, but he's just such an expert at radio repairs. He does something that hardly anybody does anymore, you know, whether it's antique tube radios or relic transistor, AM FM receivers, ham radio, shortwave radio equipment. I mean, his place is just it's a cornucopia of really cool stuff, you know, and he fixes it and makes it work. And it's really cool. So that's something we don't have so much. A lot of people, like Dave was mentioning, you know, they box up the radios, they pay a big cost, they ship it to some other state someplace. I don't know that some people know that Heartland exists. He also does installations of ham radio antennas, both base and mobile type of things. So anyway, he'll talk more about that later, but that's why he's on. He also got so excited about this that he's already on board. So he's the first one that's on board with the COMPACTenna microbeam. Okay, right. All right. So
Dr.
now you
Jack,
can see 3 photos. Yes.
Yeah, and this is Julio, and I want to interrupt your presentation to say that I was looking at your design today, and it looks pretty amazing. I went to your website and I looked them up, and I want to congratulate you. That is a really cool design.
Oh, Julio, you're such a nice man. Always have been, but thank you so much for that. As you can see from here, the antenna comes entirely in a box, and there's almost no installation. I think that's really important. I've had some 2-meter beams in the distant past, and you know, it would take me a half a day or more to assemble them. Those were large ones, but again, here we have the 2-meter dual band antenna. That's the feed that it comes with. So it comes with this. Can everybody see my arrow on the screen?
Yes.
Okay, great. Oh, that was a clear yes. Who was that?
Steve.
Oh, Steve, you have such a clear audio. All right, and it comes with the base station adapter kit. Okay, some people have been used to buying that separately from one of the resellers, to make it you know, the 2-meter dual band or the scan 3 antenna as a base station antenna. And then the instructions tell them to fold it down. These are already folded down in the box. This assembly is completely made. Everything is there. So there's even the base station adapter kit is already mounted on it. You simply screw the antenna on it and take the 2 parts of the loop, and I'm going to explain that in a moment. That's really important because I went through a number of different types of prototype designs, and they all worked, but I wanted the smallest possible because that was the whole idea. I mean, look at how small this thing is. It's only 18 inches from here all the way to here. In fact, to here, it's only about 13 inches. And the maximum element dimension is only 28 inches. You see, by using an optimized full wave loop at the proper distance, all tuned up on the Agilent network analyzer in my field studies here, I was semi-anechoic. I was able to get 7 dBi of gain with really good front to back and really good front to side ratios with the maximum dimension only 28 inches. As an example, if you look at standard antenna designs, that would have about 7 dBi or 7.8, whatever, you're splitting straws, okay? Splitting hairs, splitting hairs, sorry about that. You know, you would have a feed element from the top to the bottom, dipole as it were, that would be on the order of about 40 inches, call it 40, and a reflector of maybe 44 inches or almost 4 feet, okay? So here the max is just over 2 feet, it's only 28 inches. So it was a great way to incorporate the electromagnetic field diversity that gives you that polarization diversity, and also spatial diversity to capture signals. Because of multipath, at times what's coming at you head on is actually diminished. Now the magnetic field resonator inside with the electromagnetic field diversity will take care of some of that, but so will the side-to-side full loop. So rather than using a different design that I came up with, that was also very good and a very shortened dipole, but it was still on the order of about 34 inches, I'm able to get the spatial horizontal capture so that if one signal is coming straight at you and it's weak, that off to the side will be good. It will resonate within the loop, and then by the magnetic field coupling, create the electric field within the antenna, okay? So that was a little wordy, but that's what it does. And as you can see, when you construct it, oh, that's delayed, sorry about that. Wow, all right, let me see if I can get it. Okay, here we come. Let's bring that up. When I said there was very little construction, here you have the loop on each side. So all you have to do is bring the loop in. It's already preformed. It's in a semicircle, and tighten it down. It's very, very rugged. And the looks were important. A lot of people liked this configuration as an omnidirectional base because even if they didn't use it in the attic, if they used it on the roof, well, they said it looks like a vent pipe. Well, the whole thing has a vent pipe type of a look. So it's fairly inconspicuous. All right, presentation almost done. We'll just go down the spec sheet. This is all the description of why it works. You've heard it before, that I was able to find a way that rather than having the matching system of other types of antennas that have typically external, but even internal matching circuits, caps, coils, traps, gaps, that kind of a thing, which are lossy and don't produce an effective component of the electromagnetic field. They're just lossy, some more, some less. I found a way to eliminate that. You've heard that in my talk before about incorporating this magnetic field resonator within the antenna construct itself. So all the tuning is within the antenna construct itself, and it's an active component of the electromagnetic field generation. So it's extremely efficient. That was very key in getting a small antenna to work. So that's incorporated here. Watts, 50% duty cycle, which is very defined. There it is, 7 DI. The half power beam width, that's important. When you get, I mean, you can get antennas that are very long with a lot of gain, but if you move them just slightly, well, then you lose the signal. This has a full half power beam width of 120 degrees. That's 3 dB down. So that's 60 degrees left, 60 degrees right. So if you're within 30 degrees left, 30 degrees right, virtually no difference. You're at 6.8 or whatever dBi. I mean, you're splitting hairs. Front to back is 25. That's very good as far as beams go, especially very small ones. Front to side 15. Performances, yeah, well, that's because of the science. I do say that the VSWR is nominal, less than 2 to 1. It goes down to almost flat in certain portions of the band. So it's good across the band. That was important to get matched up right too, because parasitic interaction changes everything. It changes directivity, it changes potential lobe formings, it changes impedance on all 3 characteristics of capacitance, resistance, and inductance. So there's quite a bit of work in order to optimize a design that's as powerful as possible, but at the same time as small as possible, because that's my niche, you know, small but powerful. So this is basically COMPACTenna.com, the website. I hope some of you have enjoyed it. There's a lot of cool videos on there and whatnot. And as we go down here, we're going to go down to the models right there, and then we click on the right there, the new 2-meter microbeam. New stuff is in green, and there we are. All right, so there it is, and that's Heartland Radio. Another really interesting thing about that, since Joe is such an expert at TV antenna installation over the decades, he also knows and stocks rotors. And what's really cool about this one is you don't need you know, a $400 rotor, much less say a $1,000 rotor. You can use a television rotor. Now, some television rotors are better than others, and Joe knows the difference, but they're much less expensive because this has not only light weight, it's very low wind load, okay? And as we all know, height is so significant with 2 meters. You want to get to about that 30-foot height. So, you know, a standard like chimney mount or a high attic or that kind of thing, it's really quite impressive. So Joe Lepika at Heartland has been doing some testing with me all day on and off. I want to report on that real quick. I want you to know this is the eBay affiliate. This is not China copying things. I actually think it's a good idea to have an eBay presence of the real deal, you know, the real McCoy. So when you click on that, you'll get to a very nice site that was actually put together by his and by, it's not, Joe and I had some fun success today. For example, he's out in the Willoughby Mentor East Lake area. And we showed that we are going to be able to do some really nice simplex communication with 1 microbeam in my attic and his microbeam at actually it's going to be a very reasonable height, only about 30 feet above the ground. And that's a very low elevation out there, around 700 feet above sea level. We also had one more communication that was, well, we had a number. We talked to Canada, a Canada repeater. So, you know, almost 100 miles across the lake from Willoughby Mentor area to Canada. And then back from that repeater, almost 100 miles to me. That was fun. And one more that was really fun was talking to Ashtabula, which is about 50 miles from him and about 80 miles from me through a repeater. That was a lot of fun as well. So this little thing packs some punch, as it were. So this actually is his site. Can you see it now?
Yes.
Okay, great. Yeah, so this isn't the Heartland site. This is the eBay site, the eBay affiliate. So the actual antenna is right here, as you can see. Okay, so okay, let me open it up for questions and then turn it over to Joe.
I don't have a question, but I got a comment.
Yes.
Let's see. I remember when you were first describing or demonstrating that to Stepan and I a couple months ago, maybe, that I thought a couple of the benefits of that antenna was people that live in HOAs, housing associations, where they can't put up outside antennas, and maybe they live quite a distance away from where the repeater is of the club or repeater they want to reach. And an advantage of your micro beam, if they had that up in a closet or in an attic, that bypasses the difficulties of an HOA or having outside antennas, but then you can get gain. But even if somebody didn't live in an HOA, let's say they lived in a regular home or any kind of property, but special rural areas, they live quite a ways away from a maybe main repeater that they would get into, that and again, maybe they don't have a tower or a mast, the ability to put up something outside, that again, from their attic, and that microbeam, all you have to do is point it to the direction of the repeater you want to connect to. And I think your demonstration today, what you alluded to Ashtabula, Canada, was a prime example of that. That I think that the microbeam has a real advantage to people living out in the country, more in rural areas, not so much the urban areas where we're in, because they may not have a lot of repeaters right near them. So that hopefully would give them the extra reach that they need.
Oh, no question. And in fact, Dave, communicating with you, when I had the omnidirectional antenna in the attic, again, with the challenge of getting over that high ridge to the south, to all of you down there, as you recall, Dave, may recall, and all of you may recall, I was just barely able to make communication with you on simplex. And there's a number of ham radio operators around me with some pretty nice omnidirectional setups on their chimney mount or their roof mount or whatnot. They're right around me and they're not able to communicate with you. But once I switched to this microbeam, you told me it was like what, like on your driveway or something
right in
like
the driveway, exactly.
Oh yeah, you're solid in here now. So, you know, there's always the power of higher power radios, amplifiers, all of that, but they only increase your transmit. They don't increase your receive. And of course you can get a higher gain omnidirectional, and of course you could put it up, 80 or 100 feet. But if you can't do those kind of things and you need that extra gumption, like you demonstrated, in fact, I can hear almost everybody down there, simplex down in Medina now. Before it would be like virtually impossible. I mean, the ridge is so bad. Questions?
Jack, did you find that varying the distance between the main radiator and the reflector altered the beam width at all? And basically, how did you optimize that?
Absolutely, Tracy. That's a very good question. And Tracy, I'm also able to communicate with you now only because of the microbeam in the attic. Before, right, as you know, we couldn't do it. Now we can do it. Yes, the spacing changes everything. In fact, if you look at the ARRL book where they look at the spacing between, dipole type configurations or a dipole feed and a parasitic reflector or director, things change dramatically towards the front, towards the back, off the sides. The impedance changes, everything changes. So at the end of the day, the way I do this, Tracy, is a combination of three things. One is guided experimentation. Some people will call it trial and error, but trial and error is when you really don't focus on everything that's happening. You don't watch all the meters at the same time. That's something I just love to do. You watch everything. You watch the impedance, you watch the SWR in total, you watch the signal, you watch all the signals, you see what's going on, the front, the back, the side, all of that. And you do the exhaustive studies until you get exactly what you're looking for. You want the best overall case. The typical response to what you're saying is that you can increase the gain, but then you decrease the front to back and front to side ratio. So the noise will go up, and everything is signal to noise ratio. So you really want to try to optimize that as best you can. So there's three things, like I said: guided experimentation, I always talk about. Number two is experience. It just comes down to experience. And the third, I can't explain it, it's visionary. I put myself inside the electromagnetic flux of the antenna. I feel it, I know it. It's just something I do, Tracy. It's the way I come up with these revolutionary, unique, patented designs over the years.
Jack.
Would you like to just say a little bit about what you do up there and how you fill some special needs?
Well, I'm not real great with presentations, but you know, we've been doing radio, television work, and antennas for a little over 40 years, about 45 years. What else can you say? I specialize in radio. Radio's always been my passion since the late 60s. Tubes are my specialty. I tend to get overly excited about tube radios, so especially shortwave. Probably my favorite radio, and you know that, Jack, is the transoceanic. You know, I've always been a fan of that. But like I said, I'm not much for presentations, so.
Can I ask you some questions and you say
Sure.
yes or no?
Yeah.
Okay. So if one were to go into your shop and it's a good size, would one see like vintage shortwave tube radios, those big console things?
Oh, sure. Stuff all the way back to the early 20s. We have some stuff in and out, console radios, table radios.
So you repair these things?
Yes.
Okay, and let's see, what else might you repair for people? What about like your 1970s and 80s Pioneer or Sherwood audio equipment, this kind of thing?
Oh, yeah, we do a lot of stereo work, stereo repairs and restorations. Speakers,
speaker
musical,
retoning, and okay.
Yeah, musical instruments, guitar amplifiers, keyboards.
What about if somebody brought in a CB radio? Would you be able to tune it up, or if it had some repairs needed, some pots that needed replaced? Or do you fix CBs?
Oh, sure. We do a lot of work with CB radios. You know, back in the day, we probably had 20, 30 CBs in the shop at a time, kind of like VCRs in the 80s. But
okay.
We still get a number of CBs in from time to time.
And what if somebody came in and says, "I'd like to get one of these microbeams from you, but could you could you help with the installation? Could you do the installation on my chimney or whatnot? I hear you have done TV antennas on chimney mounts for decades. Could you do that?"
Well, sure. Yeah. We'll even do an attic installation if somebody prefers. You know, not everybody wants to climb up into their attic, but of course, I'm almost getting to that point myself, but.
All right. Okay, because there isn't much of that available anymore.
I get a lot of enjoyment out of antenna installations. You know, back in the 80s, late 70s, and into the 80s, we did a lot of C and KU band satellite dish installations, and every dish I ever installed, I still got such a kick out of how I'm getting signal from so far away.
Oh, absolutely.
Yeah.
So then you mentioned tubes on vintage shortwave receivers, AM/FM receivers. You mentioned transistors, you know, and audio equipment. What about if somebody brought in a ham radio piece of equipment that was either tube or transistorized? Would you be able to do some repairs on those kind of things?
Oh, sure. We used to do a lot of repair work on like the tube Heathkit radios, the Collins radios. I did many of those radios. The newer radios I can repair as long as parts are available. That's the hardest thing today. The biggest challenge today is getting parts. A lot of these manufacturers don't want to sell parts. Sometimes they want to just sell circuit boards. Of course, we know circuit boards can be expensive from the manufacturer, which drives the cost to where a radio may not be worthwhile to repair. But as long as I can locate a component, I can troubleshoot to a component level and generally repair the radio.
Do you also stock some of the older tubes and transistors that might be harder to get these days, but you have them available yourself?
Oh yeah, I've got quite a number of tubes that I've collected over the years and have kicked around for the last 40 years.
Okay, well, I'll make a final comment and then turn it over to Joe so he can finalize. I think that was Patty laughing in the background.
Patty.
That, yeah, that's
I vouch, we have lots of tubes.
lots of tubes. Yeah, Joe and Patty are all set up to do Hamfest, by the way, in the local area. You know, statewide, maybe a little past Hamfest. So as soon as this whole COVID and whatever related stuff is over with, do look for Joe and Patty. They're really looking forward. They have their canopy. They're all set up to do these Hamfests, you know, whether it be whatever, I don't know, Mansfield, Lima, Findlay, et cetera, but they shut them all down. So maybe certainly next year we'll be looking for them there.
Thank you very much for having us.
Thank you.